Hello, 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 and welcome back for the third and final video on one-step conversion webs. So for this, we're going to be going through two more practice problems, and then I'm going to, for the last problem, problem number 5, this is 3, can't really see it that well, we'll do 4 next, and then for 5, I'm just going to display the answer, not actually walk through it. But I would pause it for a minute so you can actually make an attempt at it first before actually looking at the answer. That way you get an idea of whether you actually understand what's going on or not. So for problem or question number 3 here, good Lord, I'm off to a great start here. What is the mass of 4.37 moles of magnesium bromide? Now, I don't have any of my markers ready, so I'm going to step over here and grab those. So, for this one, we are given the number of moles here, so 4.37 moles of magnesium bromide. So this is going to be our known from here to here. But we need to actually figure out the formula for magnesium bromide, but we can go ahead and write the rest of this down. So 4.37 moles. Magnesium is Mg. I should write that bigger. Mg. Bromide is Br. This is a +2. This is a -1. So the formula here has to be MgBr2. And then from there, we are going to... Okay, I had to pause for a second there because someone came in. So that is the end of our known here. So now we need to put a line to signify that that is the end of the known. Remember, this is technically a fraction written over 1. You don't have to put the 1. Some people find it helpful to keep it there so they remember. Okay, now we are, for this one, we started with moles. Since we started with moles, that means that we are starting here with N. And this question is asking us to find what is the mass. Well, mass is going to be M here. So we are going from N to M. If we're going from N to M, we are crossing the molar mass to get there. The molar mass is something we have to actually calculate for each one of these. So I'm going to do that over here. So molar mass for magnesium bromide is going to be Mg Br. We have 1 magnesium and 2 bromines. Molar mass for magnesium. My door is open again. One moment. Molar mass for magnesium is going to be 24.3051. Bromine is going to be 79.904, I think. Yes, 904. Obviously, anything times 1 is the same thing. So this would be 24.3051. The bottom, 2 times 79.904 is going to be 159 point other numbers. Specifically, 808. So 1 times 24.3051 gives us the same thing. 2 times 79.904 gives us 159.808. Now, we have hit equals on our calculator. That button, that's 2 parallel lines. We hit it. That means that we have to check our sig figs. So we started with 5 digits. No, we didn't. That's 6. I can't count. We started with 6 digits, so we have 6 digits here. So that one's good. This one started with 5, so this one should only have 5 as well. So we have to round this to 5 digits. So we go to our 5th digit here, the 0. We're going to underline that. The 8 is going to make the 0 go up 1, so this becomes a 1. So then we actually add this up using the 1 here. And that is going to give us 184.1151. And once again, sig figs, we have 5 digits in this number, 6 digits in this number, so this needs rounded to 5 digits. So the 1 here is our last number, so the 5 is going to make that become a 2. So 184.12. Now we take that number, and that is going to be our molar mass. So now we have to go back to our periodic table, specifically on the back side of the periodic table, the unit 4 box, the one that says MM equals, and it tells us that the number we got, the little pound sign or hashtag or tic-tac-toe, whatever you want to call it, that is the 184.12 that we just got. After that is grams, which you can abbreviate or write out. And then the formula, which is mgbr2. All of that over 1 mole of mgbr2. So that is our molar mass. That's the fraction that we need to add to this table. Before we add it, we have to go, okay, we need the things to cancel so that we get the right thing at the end. So specifically, the thing we need to cancel is moles of magnesium bromide. So we have moles in the numerator, so that means moles of magnesium bromide has to go in the denominator here. It's already in the denominator, so we just transcribe this. We don't have to flip it. So 184.12 grams mgbr2 per 1 mole of mgbr2. With another line to indicate the edge of this fraction. Now at this point, we can cancel moles of magnesium bromide from both of these, which is going to leave us with grams of magnesium bromide, and mass is what we want, so grams is where we stop. So then we can come down here to the end and put equals on both of these. So we take 4.37 times 184.12 to get the top. The bottom is 1 times 1. Obviously, I can do that one in my head. But to actually get the other one, I'm going to need a calculator. So give me a moment. So that is going to come out to 804.6044. Sig figs again come in, but we'll get to that momentarily. The units that are in this box, the unit and equation that are in the red box here, we have to add to the end of this. So grams mgbr2. I'm going to erase this because I think it's going to be in the way. So now we figure out our sig figs. We have 5 digits in this number, but only 3 in this one. So since there are 3 in this one, we have to round at the 3rd digit. So instead of 804.6044, it becomes 805 grams mgbr2. That is the final answer for this question. So I'm going to erase all this and put question 4 up, and we will continue from there. By the way, you probably noticed, I forgot to mention this at the beginning of the video, I did switch colors on the highlighter. I was told this color was a little easier to see. I feel like you can't see the number very well, but this is question 3, and we are about to do question 4 as soon as I move everything around. So I'm going to pause this and get that done. I'll be right back. And I have everything refreshed. To make everything fit, I did have to put stuff in a slightly different location, but we'll make it work. So, question number 4. If I have 0.5382 moles of lead-2 nitrate, determine both the mass and the number of molecules that I have. So for this one, the 0.58382 moles, that is the known. So we're going to put that in our box first. So 0.5382 moles of lead-2 nitrate. Now, for lead-2 nitrate, we have a metal that is not one of the ones that we just know its charge. So the lead here, Pb, Nitrate is a polyatomic ion, NO3. The nitrate is known to have a charge of -1. The lead, we know in this case, has a charge of +2 because that is what this number means. It is not the number of irons. It is, or lead. This is not iron, this is lead. This is not the number of leads that are present in the formula. It is the charge of the leads. So we have a +2 and a -1, so we have to swap those. So this is going to need a 2. So the formula here is PbNO3 2 with a line to separate that from our next fraction that we're going to add momentarily. Now, we have to decide what the unknown is. Now, in this question, figuring out the unknown is a little odd because this is different from all the other ones we've done. There are actually 2 unknowns in this problem because this time it tells us to determine both the mass, I'm pointing at the sentence, not at the conversion table here, both the mass and the number of molecules. So we need to decide which one we want to find first, and then we'll have to find the other one as well. So we're going to start with just the one that's given first in the question, which is the mass. So I'm going to make a note over here, mass, because we are finding the mass first. Now, to find the mass, if we are starting at moles, to get to mass, we are going to need the molar mass. So we need to calculate the molar mass for lead to nitrate. And I am definitely going to have to erase this. So I'm just going to do it right in the middle. So we have Pb, N, and O. There is 1 lead. 1 times 2 gives us 2 nitrogens, and 3 times 2 gives us 6 oxygens. Lead has a molar mass of 207.2. Nitrogen has a molar mass of 14.0067. And oxygen has a molar mass of 15.9994. When we multiply those out, 1 times 207 is obviously still going to be the 207. 14 times 2 is going to become 28.0134. And then 16 times 6 is going to be 95.9964. And then we have to do sig figs. Obviously, that one is fine. We have 6 here, 6 here, 6 here, and 6 here. So this one's fine, and this one's also fine, which means we're good to go ahead and add these up, which I'm going to do on a calculator. So that is going to give us 331.2098, but we have to do our sig figs on this. So with 6, 6, and 4, we want 4. So we're going to round at the 2. And since the 0 is less than 5, we just drop the rest of that, which is going to leave us with 331.2. So over here we have 331.2 grams of PbNO3 2 over 1 mole of PbNO3 2. We have moles in the numerator, so we need moles in the denominator, which means we just write this straight into here. So 330, you put the decimal point in the wrong spot, 331.2 grams PbNO3 2 over 1 mole of PbNO3 2. Obviously, you want to give yourself more room than I did right here. I'm going to go ahead and erase that because it's kind of in the way. Now that we have it, we put our marker to indicate that is the end of our fraction. We can cancel our moles of lead-2 nitrate, which is going to give us grams of lead-2 nitrate, which is what we decided we wanted to find first. There it is. Mass. We wanted the mass first. So that is what we are in with grams. So now we are ready to actually solve this. So 0.5382 times 331.2 is going to give us a number. I'll be right back. And so those two numbers give us the 178.25184. Again, we take the units inside of this red box I drew, grams of lead nitrate, or lead-2 nitrate. That goes on the end. 1 times the unwritten one here gives us a 1. So the only thing we have left is sig figs. So with a 4-digit number and another 4 sig fig number, because that 0 is a placeholder, not a sig fig, it doesn't count, which makes both of these 4. So we are going to round at our 4th digit. 5 is going to make the 2 go up. So our final answer is 178.3 grams PbNO3(2). And that's going to be it. Now, that is the first answer. That is the mass. Now we have to find the number of molecules. So for the second one here, we're looking for molecules. Now, we start in the same place. The known is still the same thing. You do not use this answer to find this answer. The known is still the same. We still start with 0.5382 moles of lead-2 nitrate. So we write that here just like we did up top. 0.5382 moles of PbNO3(2). But this time, instead of going from moles to mass, we are going from moles to items. So instead of using the molar mass, we are going to use Avogadro's number. So Avogadro's number, instead of being this thing we have to calculate, is a constant. We know it. All we have to do is write it down. So I'm going to do the same thing here. Write it underneath. See if we need to flip it. And then I will put it in. Now, some of you are probably at the point where you don't need to actually do this anymore. And that's fine. If you can figure it out in your head, then you can just write it in the correct spot. Just double check by crossing stuff out. And make sure that you actually have it in the right spot before you start trying to actually solve it. So I'm going to put this underneath. We know Avogadro's number is 6.022E23. After that, the units are items. So it's either atoms or molecules. This is a compound, not an element. So we are after molecules. So moleculs. And then the formula, which is again the PbNO3(2). All that over 1 mole of PbNO3(2). So now we look at this. This is the fraction that we need to put in. We have moles of PbNO3(2) on the top, which means we need those moles to be on the bottom, which is how it is already written. So we can just plug this straight in. 3.022E23 molecules of PbNO3(2) over 1 mole of PbNO3(2). We have a line to indicate the end and a canceling of the moles of PbNO3. That is not where I wanted that. This one. And that's going to leave us with molecules of PbNO3(2), which is what we want. Right here it says molecules. That's what we are trying to find. So now we're ready to actually solve this. So I'm going to put equals for the top and the bottom. As per usual on most of these practice problems, because they're only one step, the denominator is going to be 1 times 1, but the top is going to be just a slightly bigger number. So I'm going to calculate that. Actually, no, I'm going to actually show you guys how to do this, because we need to go through how to actually enter a number like this into the calculator. Now, I'm going to show you how to do it on my calculators, the ones we're using in my class. So first off, I'm going to take this number and then plug this one in so that I can show you how to enter this number. So first you just enter the 6 point, you can't see it real well, or I can't, but there is a decimal point right here, 6.022. Okay, so it says 6.022. And then what I want is I want to put in an E, a capital E. You may or may not be able to see it, but right there above this key, it says EE. So what's written above each of these, you access by hitting the second key. So I want to put an E in, so I need to hit the second key first. So I'm going to hit second, and then I'm going to come down and hit EE, and that's going to put an E in on the calculator. Now I just enter the exponent, which is 23. So it actually displays like this. Now if I just hit equals, and this is important when you have to actually read an answer, you'll see when it displays the answer down here, it actually says 6.022, and then real small here it says times 10, and then 23. Anytime you do a calculation with one of these, and you have Avogadro's number in the question, you need to check and make sure whether you have a times 10 to the at the end of the question, or at the end of your answer. Okay, it's easy to miss, so make sure you've got that on there. Okay, so now I'm going to take this times this to get my actual answer. So times 0.5382, yeah, equals, and that is going to give me 3.241040 for E23, because the E just means times 10 to them. And then units, molecules of PBNO32. And that leaves us with sig figs. Now, when you are figuring sig figs on a number that is in scientific notation, the E does not count. There are 4 sig figs in this number, 6, 0, 2, and 2. The E23 doesn't count towards your sig figs. So we have 4 here and 4 here. So here we want 4. So our 4th digit is this 1, which the 0 is not going to change. So I cross out the rest of this, but not the E23. That has to stay. So I'm going to cross out this, but stop at the E. I keep the rest of this. So then I come over here for my final answer. I'm going to proactively erase this because I think it's going to be in the way. So 3.241, almost forgot it, E23 molecules of PBNO32. And that is the second answer for this question. So you actually have to do 2 tables because we want 2 answers. So this is the mass, this is the number of molecules. So I'm going to reset real quick and put question 5 on the board. And once I have that up, actually I think I can just scroll down and put it. I can just put it down here at the bottom. Have you guys pause the video once the question is up, and then make an attempt at it. Try to get it. It's going to be similar to one of the problems that we have done in the last 2 videos. Either 1, 2, 3, or 4. It's going to be similar to one of them. So I'll pull that up real quick. So here we go. I have 2 moles each of tin 2 fluoride and aluminum sulfate. Of which do I have more mass. Okay, so write that down. Pause the video. And actually, I'm going to say pause the video. Write the formulas for these names. And then, because that's going to be good practice, I will put the formulas up momentarily. And then you can actually pause it to work the rest of the problem. So first, write the question out. And now, pause the video now. Okay, I've given you time to pause. I'm now going to work out these names. So I'm going to erase this, because I don't need this anymore, and it's kind of in the way. So I'm going to use purple for this because it's a known. So tin, this is the first name, by the way. This is the second name. So tin is SN. Fluoride ends in "ide," so it's not a polyatomic ion. It's a simple anion, so it's just fluorine. But the "ide" tells us that this is the most common ion, which is a -1. The 2 here tells us this is tin 2, so a +2. The charges do not cancel, so we swap them and drop them. So this is SnF2. For aluminum sulfate, aluminum is Al. Sulfate, that ends in ATE. That is a polyatomic ion. It's one of our exceptions that we learned early on. Sulfate is SO4. It has a -2 charge. Aluminum, the metal charge, is not here because it's one of the 15 metals I told you that you were going to have to memorize. Aluminum is always +3. So with a +3 and a -2, the charges do not cancel again, so we have to swap them and drop them. So Al2 from the sulfate, SO4, and we need a 3, which means we have to put the parentheses. So these are your formulas that you need to answer this question. So now, pause the video again, and I will momentarily put the answer up so that you can actually see the correct for this. I am not going to work through this. I'll give a quick summary of how to get it, but I'm not going to actually work it all out because it's all typed out. All I have to do is put it up. So I'll step off screen and reiterate, this is your last chance. Pause the video. Okay, now I am going to put the answer up. And here is the answer for question 5. So the actual answer is I have more grams or more mass of aluminum sulfate. Okay, that's the answer to the question. To prove that, you have a couple different options. So since we are after the mass and we are starting with moles, we're going to mass, that means we have to use the molar mass. So if we calculate the molar mass for both, we get that tin 2 fluoride has a molar mass of whatever this number is. There's a line in the way, I can't see it. 156.708 grams per mole, while the aluminum sulfate has a molar mass of 342.15 grams per mole. Now, if we have the same number of moles, then we can actually use this information to figure out the answer without doing the conversion table, without actually calculating these two numbers that are behind me. If this molar mass is smaller than this one, and I have the same mass of both, then I have I have the same number of moles. I have 2 moles of this and 2 moles of this. I have to have more of this because 1 mole of this is more than 1 mole of this. So I have to have more aluminum sulfate. Now to prove that, if you want to double check or make absolutely certain, or what I just said doesn't make any sense to you, you can build the conversion table. So here is the molar mass. We have moles. So the moles are set up to cancel, which will leave us with grams. Multiply these two numbers. We get this number, 313. No, this does not have the correct number of sig figs. It should be 3, which is 313. This one down here, same thing. We have the moles canceling. So we take 2 times 342, which gives us 680. So 300 versus 600. 600 is bigger. We have more mass of this. So we have more aluminum sulfate than we do tin 2 nitrate. No, tin 2 fluoride. Tin 2 fluoride. So that is where I'm going to stop. I'm going to step over here so you can see the whole thing again. That's where I'm going to end this video. For the next video is going to be over 2-step problems. So at this point, you should be going through and working through worksheet 4.1 if you have not already started on it. Worksheet 4.1 has 14 problems on it. Question 6 is similar to this one. Okay, it's similar to this question. It's a 2-part question where you have to calculate 2 things. Questions 7 through 10 are more like questions 1 through 4. So if you're a little unsure, start with 7 through 10. Work on those. Once you've done those, then go back and do 6 or 11 through 14, however you want to do that. 11 is, I think, the hardest problem on there. 11 and 14 are the 2 hardest problems on the worksheet. So you might save those for last, or if you're just going, I don't feel like doing this, I'm going to skip to the hardest ones to prove to Mr. McCorkindale that I don't need all this practice, then you can do 11 and 14, get the answers for those, and you'll be good to go. I do not have the key quite done as of the time of recording this video, but I should have it by the time I post this video. So tomorrow during class, that's Thursday, February 2nd, the key should be linked to the same place this video was. So you should be able to access the key from there to check your work. And it should look like this, where it's actually got everything worked out. Except for how to get the molar masses, because you guys should know how to get those by now. So that is where I'm going to end this. Have a wonderful day or night or whatever time it is. And I will see y'all in the next video.